Okay, so I'm going over the peak FRQ's solution now, and the first method you had to implement was the is increasing method, which once again was supposed to return true if the array was increasing the whole time before spot stop, really up to and including spot stop. And so first of all, the loop will loop up to the spot before that, because inside the loop we'll compare the current element to the element after it. And so you better not actually go up to this spot. And then you got to get the logic here. And what I mean is that we're checking to see if it's not increasing at any given point. And if it is, we immediately end. We return false immediately. So we only return true if we loop through the whole thing. It didn't find anything out of order. Now some people tried to, like they made a Boolean variable at the front and to store the answer, and they try to set the variable inside the loop. The problem with that is that, think about this, let's say you had something that goes up and then down, or up and then down, and up and then down, then you'd be setting the answer to be true, then false, and true, then false, and true, then false. And when you're done, you return whether it was increasing or decreasing at the end. But that's flawed. We want to know if it was increasing the whole time. So if you find any single place where it's not increasing, you just return false immediately. So for this kind of method, do not create a local variable and return that variable. Rather, just return the answer inside the loop. So here's the code. As I said, you go from spot 0 up to, but not including spot stop, because you're going to compare the current spot to the one after it. And if it's bigger, then you return false. Frankly, it didn't really worry about if it's equal. So if you put equals, I give credit. Either way, it was okay. Anyway, and of course, I have J here. You can have I or whatever variable you want for the loop control variable. But anyway, there you go. Like I said, return false inside the loop if you find something out of order. Otherwise, return true at the end. Now, there is decreasing method, which you did not have to implement, but you were supposed to know it was there. And so let's just talk about it real quick. Is decreasing is given a starting point, and it checks to see whether the array is decreasing the whole time from that starting point up to the end. And so it's going to compare an element to the one after it. And this time, though, if it's smaller than, that's bad. That means it's not decreasing. You return false. So the same logic, just kind of turn around for decreasing. Also notice this loop starts at the parameter start, and it does not go to the last spot. It stops at the second to last spot. So the last spot it hits is spot length -2, because once again you're comparing an element to the element after it. All right, now the next one you had to implement was the get hill index, which once again is just supposed to see if find the location of the first hill. And a hill is defined as an element that's bigger than its neighbors, each of its neighbors. And because we're searching, or we're trying to compare to the predecessor and the successor, you need not to start at the beginning. You need to start at the second element and stop at the second to last element. And once again, if you find what you're looking for, you return that location immediately. You don't store it, you just return it. And if you get through the whole thing and didn't find a hill, then you return -1 after the loop. So here's the code. Once again, start at spot 1, start at the second spot, end at the second to last spot. And what I said was, if the current element's bigger than the element before it, or you can say it this way, the element before is smaller than the current element, and the current element's bigger than the one after it. Now I want to address, like I had a number of people, they phrased it almost perfectly, and they were going with what I said, where the current element's bigger than the one before it and after it. And notice how I just said that. The current element's bigger than the one before it and after it. I didn't say the current element is bigger than the one after it. And people, they leave this part off right here. But you need it in both places. You can't just drop it and just have this here. It won't compile. And so be careful about that. And then once again, if you find a hill, you return immediately, because otherwise you'd be returning the last hill instead of the first hill. If you like stored it instead, no, you want to return as soon as you find a hill, and you return its location, and then of course return -1 if there were no hills. One more thing, some people try to do special code for spot 0 in the last spot. it was unnecessary. Unnecessary, because once again, if you don't find a hill anywhere in the middle, then you just return -1, and this code works. All right, finally, the isPeak method. You first of all, once again, you're finding the first hill and checking to see if it's a peak. And by a peak, we mean the array is increasing the whole time before that and decreasing the whole time after that. So you call get hill index and store it. Now, when I did this before, I had the word peak there, which is a bad name because we're trying to see if there is a peak, if the whole array is a peak. Whereas what this gives me is the location of the first hill, so either hill or first hill would be a better name for that variable. So once again, you find the first hill, which there may not be one, in which case this would be -1. So then you want to say, okay, is there a hill, as in is it not -1, and is it increasing the whole time before that, and then is it decreasing the whole time after that? And let me say again, you could phrase it this way, where if that's true, you return true, else return false, but I would just put this condition inside the return statement and just return the value of the expression. So here's the code. Once again, call it get hill index and store it. Check to see if there actually is a hill, and then call is increasing. And you need to go back and look at these methods and make sure you're calling them correctly. Some people, once again, are trying to call them on the array. You don't do array.isIncreasing. Arrays don't have an isIncreasing method. This class had an isIncreasing method. And you gave that method an array, and like here for isIncreasing, you gave an array and a stopping point. For isDecreasing, you gave an array and a starting point. And so this would work. It would check, when you call isIncreasing, it's going to check everything from spot 0 up to where the first hill is, and return true if it's increasing the whole time, or never decreasing. And then here it'll check from this starting point to the end and return true if it's decreasing the whole time. And once again, you didn't need an if else. You could have, but this is shorter. One last point. Some people, instead of checking whether it's decreasing, they checked whether it's not increasing. They're not the same, because like here, this example, it would not be increasing or decreasing the whole time. It goes up and down, and then up and down, and up and down. So mathematically, I would say it's not monotonically increasing or monotonically decreasing.